Hi all, this is day 97 of my grade CS prep. So I was doing the lecture where asymptotic notation started with big O notation and examples on it. So I'll be explaining the example that I have done and a few points on asymptotic notation and big O. So you can see there is t of n function and the expression and then g of n. So we need to find if t of n is equal to big O of g of n. So find that we need to first find n naught such that it dominates the t of n. So you can give the example. So you can see on the right side n square is there, so automatically it will grow. Then I've taken c equal to 1 and n not equal to 10, but it does not satisfy. Like 130 is not less than or equal to 100. So again, took the different values like 1 and 20. So it gives true and it's satisfying equation. It's very like basic equation. You need to check if it satisfies with taking different values. And then the second part is asymptotic comparison between two functions. Like most dominating term you need to take from the both the functions. So here you can see n square is definitely greater than t of n. So t of n is less than or equal to c dot g of n, this equation, which means t of n is equal to big O of g of n. This you will be seeing for more in next example, that if it is t of n is less than or equal to g of n, then it's t of n is equal to big O of g of n. So this is the meaning we need to keep in mind. Then second example is also we need to find if these two equations are same, like it is satisfying. So most dominating term you can see n square, we have taken n, then n square is not less than n, so t of n is not less than g of n, so it does not satisfy. And if t of n is not less than g of n, then t of n is not equal to big O of g of n also. You can see the same thing. So that is a conclusion. If and like t of n would equal to big O of g of n if and only if it is less than or equal to g of n. That's what we have started with from the first example. So big O can be written as less than or equal to for asymptotic comparison. For the function t of n g of n, if t of n equal to O, big O of g of n satisfies, find Cn and not. So you can see first if two constants Cn and not exist such that this is the meaning of equation. But what if it does not exist, only this t of n is equal to big O of g of n? So this is waste of time. So to avoid this waste of time, we should do first asymptotic comparison, which is comparing the most dominating term from both the equation, and if it is not less than or equal to, then it won't be equal to big O of g of n also, and then c and n naught does not exist. So that's the time saving trick. You can see here we are comparing first like n and n both are equal. So if both are equal, then it's definitely less than or equal to g of n. You can see I have written yes here. Then we have find the c1 and n naught, like 1 and 100, taking c equal to 1 and n naught equal to 100. $700 and $800 from here, like this is less than equal to a g of n, so it does satisfy. Asymptotic comparison, n square greater than n, so no, this is the case where this is greater than and it is not less than or equal to g of n, so not less than or equal to big O of g of n also. So here same n cube. So this is, since it's equal, t of n is less than or equal to g of n, and then we need to find c and n naught. You can take any value, like we have taken c equal to 2, so which is satisfying, and n naught is 1. Here check if first like these two are equal. So we are doing the asymptotic comparison, and you can see in T of n it's 1000, which is completely constant. So constant you can take 1 because does not matter what we take for constant value, because constant does not contribute to growth rate, so it's negligible or insignificant, you can say. So n is definitely greater than 1, so T of n is less than or equal to G of n, and we need to find Cn and not. Once n dominate 1000, it will dominate always. So you need to find only one n naught, then after that all the value will dominate the n, like 1000. So 1000 less than or equal to n, and we have taken 1 and 1000, so it would satisfy the equation. You can see it satisfies. N plus 3 5000, so here it would be n, and here it would be 1. Again constant, you can take 1 only, so it's not less than or equal to, so does not satisfied. And if does not satisfied, big O does not exist, and we can't find the C and N naught values. So here is one main example, and there are very sub questions inside it. We need to find true or false. So it is like T of n, it's 60 n cube plus 70 n square plus n plus 1000, and from here we can see most dominating term is n cube. First question we need to find true or false is T of n equal to big O of 60 n cube plus 70 n square plus n. So from here most dominating term is n cube, and we, like from main equation also we got the n cube, so both are equal, and so this satisfies less than or equal to n equation, and big O also satisfies, so it's a true. It's very straightforward. You need to find the most dominating term from both the equation. So you can see here both are equal, like given sub question has n cube as a most dominating term, and main equation also has most dominating term n cube, so big O satisfies because it's a less than or equal to n cube, so it's also true. Here again n cube you can see along with constant 30, and which is equal, so it is less than or equal to n cube, satisfy big O, n cube true. Then 70 n square is less than or equal to, I mean n cube is greater than n square, so it does not satisfy Tn less than or equal to G of n, so it does not satisfy big O, so it's false. And here 500 n square, this is not like n cube is greater than n square, so T of n is not less than or equal to G of n, so does not satisfy big O, and it's false. Again n cube is greater than n square, which is not equal to T of n is not equal to G of n, it does not satisfy big O, and it's false. So T of n is equal to big O of n cube greater than n, so it does not satisfy, so it's big O, so it's false. Here 1000 you can take 1, and n cube is definitely greater than 1, so again it does not satisfy big O, and it's false. So here n cube is most dominating term, which is equal to the given most dominating term, so it's true. And from here also n square is most dominating term, n cube greater than n square, true. N cube is less than n5, so it satisfied T of n less than or equal to G of n, and it satisfies big O, so it's true. So there is conclusion kind of thing is big O can be used to represent the growth rate by picking most dominating term. So we can write T of n equal to 60 n cube plus 70 n square plus n plus 100, and T of n is running time. Also as T of n is equal to big O of n cube, like this is most dominating term, and it would be T of n less than or equal to n3 and n cube, and so on. Like after n cube it would be less than or equal to any power, like n raised to 4, n raised to 5, and so on. So T of n is a time complexity here written as big O n cube. How to read in terms of time complexity, like T of n equal to big O of n cube, can be written as T of n less than or equal to C dot n cube for all n greater than or equal to n naught. For any input of length n greater than or equal to n naught, algorithm will take at most C dot n cube time. So this is some conclusion that we can do in terms of big O also, like time complexity and running time in terms of growth rate. So that's all for this video. This was first asymptotic notation, which is big O. And I have done with the example. I'll be starting the second, which is big sigma or whatever the second is. I'll record that also. Thank you guys for watching.